Okay, hi, I'm Drew, and on behalf of HS Navigator, today I'm going to talk about the wonderful world of data analysis. It is still a developing field, and new tools and techniques are still evolving around it every day. It is increasingly becoming more and more important in our everyday lives. If you have any questions, you can put it in the Q&A chat. Data analysis, importance. Data is money in today's economy. It is the biggest asset for big companies like Facebook, Amazon, Google, Yahoo, etc. And data is basically the way they make money. It helps businesses improve specific aspects about their products and services. And data is required for almost any large company to be competitive in the market. And there is high growth. There is high growth in the jobs in this segment. Impact on society. The government policies based on census are based on census data analysis. Potential to impact opinions of large populations by messaging directly to targeted people. For example, Facebook's recent impact on the election seemed to skew votes towards one direction. The ability to swing sentiments through social media. Data science is being used for analyzing medical images, genetics, and genomics. It is also applicable to the development of drugs as well. It can detect risks and frauds in financial sector. So as you can see, data has various broad uses in today's society. What is data? Data is any information that can be stored, collected, and analyzed. And believe it or not, data is not a recent phenomenon. It's been used for a very long time. And for example, you can see in prehistoric times, data was used to, for example, track kills by different hunters. And based on that, they'd analyze it and give different roles to different people. And then in the past few centuries, weather tracking has started. And that is also a type of data analysis. And then very recently, a type of data storage plays a role in sports scores, in tracking sports records. What is data analysis? Data analysis is defined as a process of cleaning, transforming, and modeling data to discover useful information for business and decision making. Through data analysis, you can also detect the weaknesses and strengths of your competition, uncovering opportunities for improvement. Analyze online reviews about your competition to answer questions like, what do customers love or hate about your competitors' products or services? So what is data analysis? It is the process of extracting meaning from data, and it involves the following steps: data collection, data cleaning, data grouping, data aggregation, and data visualization that we'll dive deeper into in the next few slides. The outcome of the steps above include one or more of the following: understanding the past and current scenarios and showing what already happened, future projection, which shows what might happen in the future with a prediction, and discover valuable insights, show some hidden factors that were unexpected or not directly visible. Data collection. This is the first step in analysis, and we need to focus on items like, is the data already available in the organization? Do we need to merge data from different sources, or are they all available in one area? Are there legal requirements to be met? For example, privacy laws that tell who can gather what data for how long, etc. Do we have or can we get all the data that is needed? Because sometimes we may not be able to collect everything required based on time, volume, cost, expertise, etc. Are the data all in the same formats? Excels, CSV, database tables, JSON, or different time zones encoded? Data cleaning. Once we have the data, we may need to make sure it has only the relevant data. Is the data well structured with well-defined fields? Can we easily merge the data from all the different sources together? Are we missing any values, or is there a data gap? A time series may have missing data for a few months, or sales data may be missing 1 second. Is there granularity by date, by products, etc., the same across all data sources? Do we need to keep data updated frequently? Does the data get stale or out of date? Before we move on to the next steps, we may need to remove inconsistent and superfluous data from the data set, or remove outliers from our data set. Interpretation and visualization. Once data is collected and cleaned, analysis can be performed. Visualization will draw meaningful and actionable insights. Creating visualizations will help show results. It must be easy to comprehend. We should not need to do another analysis on the data findings to understand it properly. It must be actionable. If analysis shows something which cannot be acted upon, then it is not worth doing. Use dashboard or storytelling to convey the findings. The data analysis. What is the need? It turns data points into meaningful insights. It highlights areas for improvement. It reveals the best direction for organizations. It shows future trends. It measures the impact of marketing outreach. One example of successful data-driven product is Google Nest, which collects, analyzes, and learns from data to improve its usability. Data analysis, use cases. Market research, how much of a market share the company has, which area the company needs to focus. Product research, is the product needed by customers? Which features of products are being used more? Customer reviews, what customers liked or disliked about the products. Sentiment analysis, reactions of customers to promotions, company initiatives, tweets. Competitive analysis, who are the competitors and what are their competitive offerings? Data analysis, types. Below are the major data analysis types. We will talk about these more in depth in the next few slides. Descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. Data analysis, descriptive analysis. The goal of this kind of analysis is to answer the question, what is happening? It uses historical and current data to show what has happened in the past and what is happening now, both with the company's data and with surrounding landscape, including competition. It shows trends and patterns in present data. For example, Amazon.com finds that all items are being shipped very late since the past week. Data analysis, diagnostic analysis. This analysis tries to provide the details on why is this happening. Once your descriptive analysis shows that something negative or positive happened, diagnostic analysis can be done to figure out the reason or reasons behind it. It provides the connection between the data and the trend and tries to find out what factors are driving the trend. For example, continuing out to a previous example of the delayed shipment in Amazon, diagnostic analysis finds that some automated robots shut down in the warehouse, leading to delayed shipment. Next, we have predictive analysis. This analysis shows what is likely to happen. It uses insights from descriptive and diagnostic analysis. It extends the trend from past data to create a forecast or predict the outcome for the future. And the example will be, the shipment will continue to be delayed for the next 3 weeks. Now we have finally the prescriptive analysis. It is the most useful analysis for major companies. It creates future plans and direction for these companies. It involves advanced techniques of machine learning to come up with solutions for desired outcomes. It requires lots of effort and resources as it combines insights from all previous analyses. Notable examples: the tracking of seasons and the birth of the calendar. Before the calendar was created, people used data of different temperatures and patterns that repeated over time, and they noticed a consistent pattern repeating over and over. And based on that, they made the calendar with the repeating seasons. Another example is Moneyball. Data analysis helped create high-performing and the winning baseball team. Low on a budget and unable to hire top-paid players, they used the analysis of different metrics for each baseball player, including how different players played along with each other, to identify bargain players and build a team with them, which went on a 20-game win streak. And they used data analysis to find the proper combination of different players with different skills to make the most effective team. Moneyball is also a great book and equally great movie, showing the power of data analysis to achieve great things. Data analysis tools. Data analysis requires a combination of various tools. In addition to databases and SQL, some popular tools are listed below. There are many other tools in use as well. There's R, Python, Java, SAS, Click, Tableau, Excel, and KNIME. Data types. Data collected for analysis can be grouped into the following types: structured data and unstructured data. Data types: structured data. All data components are formatted to a set structure and are formatted into precisely defined fields. They are mostly stored in relational database. It is searchable and easily queried with SQL. Different systems and algorithms can utilize this data without much effort. It is easy to comprehend for analysts. There are more tools that have been tried and tested using and analyzing structured data. It is easy to integrate with new or other external data sources. Examples: any inventory management system, library bank, reservation systems, Uber, etc. Then on the other hand, we have unstructured data. This data is in its native format, for example, .doc. Examples are surveillance photos and videos, emails, PDFs, social posts, tweets, Internet of Things, sensor data, satellite imagery, etc. This data needs to be cleaned up and transformed into an easily searchable form. It has faster accumulation rates. There is no need to predefine the data, which means it can easily be collected and quickly be collected. It takes more time to analyze this data, however, as we need to understand the data structure first, because it is previously unstructured, and then need to extract the information, then transform it to work with other data sets. Specialized and limited tools are needed to process such types of data, and this cannot be easily grouped, aggregated, or searched because it is unstructured. Data size. Data size has been increasing exponentially in the past few years. There will be even more data in the coming years with connected devices and automated driving vehicles, Google Assistant, Alexa, product reviews, social interactions, wearable devices, etc. And on the graph on the right, you can see the exponential growth of the size of data. In the early mainframe era, that you could see what little amount of data there was in the world. And then as we moved into the PC era, we started hitting terabytes and petabytes. And then we moved into the internet era with social media. And then the size of data started becoming even more larger. And now in the virtual era, the size of data is about to hit a yottabyte, which it's not hit a yottabyte yet, but it's about to in the near future. And over here you can see the different types of units for data size we have used in the past. And as data is becoming more and more, we'll be needing more units. We have kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, zettabytes, and yottabytes. Data analysis techniques. The first technique we have is regression analysis. Regression analysis is a set of statistical processes used to estimate the relationship between variables. It shows how changes from one or more variables might affect one another. For example, how might social media spending affect sales? Next, we have cohort analysis. Cohort analysis is used to break a data set down into groups that share common characteristics, or cohorts, for analysis. This is often used to understand customer segments. For example, e-commerce companies or digital advertising companies can choose to show one version of advertisement to one set of customers and another version to a different set of customers in order to properly target the right audience. Our next technique will be cluster analysis. This analysis classifies objects or cases into relative groups called clusters. It can be used to reveal structures in data. Examples: COVID spread analysis can highlight areas with high rates of infection. Insurance firms might use cluster analysis to investigate why certain locations are associated with particular insurance claims. Our next type of data analysis will be time series analysis. Time series analysis deals with time series data, or trend analysis. It is frequently used for economic and sales forecasting. Time series data means the data is in a series or particular time periods or intervals. For example, companies provide their quarterly forecast. Now we're going to move into storage. Data cannot be handled by spreadsheets, Notepad, or other simpler applications, large amounts of data. They need specialized systems to store and process these large amounts of data. When you have such a large amount of data with millions and millions of entries, our simple everyday software cannot properly handle them or cannot perform tasks on them. And that is why we need softwares such as Apache Spark, Hadoop, Teradata, Oracle, Amazon Web Services, etc. Because these companies provide a proper system where large amounts of data can be stored, processed, and searched easily and efficiently. Now we've been talking about data itself, and now we're going to start moving into data analysis. Okay, case one. I'm assuming everyone is aware of the Krusty Krab restaurant. They make delicious Krabby Patties in the restaurant, serving the local population. And if you have not tried it, you definitely should go ahead. At the end of a hard day, SpongeBob and Squidward can recollect memory from all the sales and determine the profit or loss inventory, and can record it all in one page easily. As shown in this table, they have the date, the number of Krabby Patties sold, the number of other patties sold, and the total profit. And this will probably take around 1 minute at the end of every day for them to write it down, as the Krusty Krabs isn't a big restaurant. However, as opposed to the Krusty Krabs, we can look at big companies such as Walmart and Amazon. They have millions and millions of transactions across hundreds of stores across the world, and they cannot easily record transactions locally. They have like over 1 million times what happens in the Krusty Krabs, and employees cannot simply go through their data every day and look for systems efficiently. So this is where data retrieval comes in. You cannot review all transactions manually. The list is simply way too big for any application to handle. They need mechanisms to properly and efficiently query and aggregate the data. And one way to do this is using SQL. Data aggregation. Here are some data aggregation performs tasks on data, and here are some examples of data aggregation. The sum, which can be used for total profit or total sales. The average, which can show the total average visitors of the store every day. The rank, which can rank products that are performing better or rank products that are performing worse. Year over year, how is the store doing this year compared to the year before or 2 years ago? Month over month, similar to year over year, except you're using months instead, comparing this month to the previous month. And then median, what is the quantity being ordered most frequently? And there are also a lot other ways of data aggregation. These are only a few. Data review, pivot table. A pivot table is a very useful and powerful tool to look at data in different angles and properly visualize it. And these are some examples of pivot tables that help properly look at data in an organized format. And as you can see here, we have tabular data over here with categories, months, and amounts. And then on this table on the right, it is more concise as we have grouped the months into columns with the categories in each row and summing the grand total on the right and the bottom. So this table is more concise and more formatted based on the months. So this shows how we can transverse the rows into columns and look at the data from a different angle or different perspective. Data visualization. It is a process of describing information and findings through visual readings. It showcases the data in a way that the human brain can easily absorb. On the left over here, you can see a bunch of random numbers and data information. However, by looking at such a large amount of numbers, you probably can't identify any clear trends or patterns in here. However, if you use these numbers and put it into a visual graphic format, then you can likely see some trends. For example, on this map, you can see the red areas generally on the right side, while the green areas generally on the left side. Or on this graph, you can see a general downward trend. While you could probably not identify any of that over here with random numbers placed next to each other. Data visualization is worth 1,000,000 points of data. The dashboard as shown below can be used as a digital cockpit. The information here can be easily understood and can lead to the user focusing on the needed areas and guide the company in the right direction. Once again, when companies have searched such large amounts of data, they cannot analyze it properly without a visual representation, as shown over here. Next, we'll be looking at a scatter plot. The first step of data analysis is generally a scatter plot. It shows a relationship between two variables, and outliers can easily be identified. And this plot on the right shows that the more time you spent on the game, the more points you will score, as you can see here. The x-axis is the time played, and the y-axis is the points scored per game. And these are various data points. As you can see, there's a general upward trend. You can make a line of best fit through here. And these are two outliers that could be accepted. Next, we'll be looking at the best practices. Speak to a specific audience. Creating nice visualizations and putting them together in dashboards is not just an exercise in providing information to the masses. This is a case where one size does not fit all. We need to know who this visualization is for and what their end goal is. And based on that, we can choose different types of representations and visualizations for our data. It should alert the viewer of any outside the norm activities. Data visualization best practices. The chart type must be selected carefully. For example, the tables show a lot of information in a structured way, but may overwhelm the users who are just looking for high-level overall trends. Line charts track changes or trends over time and show the relationship between two or more variables. Each chart type serves its own purpose. Depending on the goal, the data analysis, and the audience, the chart type must be chosen so that it is actionable properly. Next up is providing context. Context engenders trust, which leads to proper action. An excellent data visualization technique to help demonstrate the performance would be the use of color, arrows, text, and other visual cues to help the viewer see at a glance how to interpret information and charts shown on the dashboard. Not only do users need to see the chart and the outcome, they need to feel comfortable in using those. Chart must provide clear and concise way of providing the information that leads to the outcome. Keep visualizations and dashboards simple and digestible. Too much of anything can become toxic. The same logic applies to visualization. Keep the dashboard simple enough to convey the message at one glance. The user should be quickly able to understand a high-level overview and should have the ability to dig deeper if needed. Don't clutter the space with unnecessary and complex information. Make it simple, concise, and easy to grab the overall concept of. Data visualization, scatter plot. The scatter plot is very helpful in understanding if data set is new and not enough information is available. And we have 4 examples of scatter plots on the right. This scatter plot has a strong positive and linear correlation. As you can see over here, it strongly supports a linear line. Over here, we have a moderate negative linear. String because while you can see an overall negative trend, it is slightly spread around, so you don't have a very strong correlation. Over here, there is null or no relationship. As you can see, there is no positive or negative relationship. There seems to be no strong relationship between the x variable and the y variable. Hence, it says no relationship. And finally, we have a strong nonlinear relationship. We have most of the data points fitting a parabolic shape very strongly, hence a strong nonlinear correlation. Data visualization, bar plot. We have a stacked bar chart comparing different consoles within different regions. And over here, you can see the names of different consoles and the units sold in millions. And this is the key showing different regions of how many consoles are sold. And as we can see over here, even though the Game Boy is 3rd overall, it appears to be the 1st within Japan. And if we look at the Game Boy, the overall sales does seem to be the 3rd. But then if you look at Japan in green, it has the largest screen section. And by using this visualization, we can easily find this data at first glance. While if we had a bunch of numbers on a table, we probably wouldn't be able to decipher this easily. Data visualization, pie chart. Pie chart shows a fraction of a whole, and it is used to compare different categories easily. So this is an example of a pie chart. Reasons for ending a game of Monopoly. The blue small sector shows if somebody won. The red shows everyone quit after 3 hours of playing. And most of the time the green, somebody flipped over the board in rage. Data visualization, time series. Looking at activities over time, there are 2 components. Trend, the overall sales increasing, and seasonality. Every December, the sales goes up and then comes down, which is referring to this graph over here. On the x-axis, we have various dates, and on the y-axis, we have units sold. And then throughout the graph, we have 3 different lines representing the 3 consoles that we're comparing. And as we can see, during this time, during 2007 December and 2008 December, we can see unusual spikes in sales, which refers to seasonality. We can decipher that every winter, the sales are likely about to jump and then go down after. Next, we have data visualization map. This map shows the COVID spread across the country. And once again, this map is a much better visualization than a bunch of numbers and their respective regions. And based on the map, we can look for certain patterns in the white areas and compare it to the differences of the red areas, and then implement that into society to make the overall COVID cases lower. Data visualization, other chart types. We have the donut chart shown on the bottom left, which is similar to a pie chart except more readable or sometimes more comprehensible. Then we have a candlestick chart on the top right. It is generally used in finance. And as you can see, there are different sectors of it. For example, in this case, we're looking at a stock, the opening price and the closing price, and the daily high and low of the stock. Then we have a Sankey chart on the top left, used to see the movement of items between groups. And for example, we can see where different demographics are, where the votes of different demographics are going from the left to the right. And finally, we have the funnel chart, shown in the bottom right. This is generally used in sales and marketing. And one example of this could be looking at Amazon's website. The blue section could represent the number of people that logged onto the website and browsed through it. The orange section could be the number of people that added some items to their cart. The green section would be the number of people that went to the checkout page. And the smallest pink section would be the small portion of people that actually purchased items. Now we're going to look at some tools for data visualization. Below are some tools for creating data visualization, each having their own pros and cons. Excel, Google Sheets, Tableau, Click, scripting in R and Python. However, these are only some examples and there are a lot more. Data visualization, tool features. Features of good visualization tool. The ability to properly and efficiently handle large amounts of data that can also exceed 1 million records. The ability to merge data from different and varying sources. Control who can see what, also known as data security. It must be able to refresh the data and visualization at some frequency. Show a dashboard with multiple visualizations grouped together. Provide the ability to interact with the dashboard, such as data filtering. Support many chart types. Next, we have Tableau. This tool can connect hundreds of data sources and types, such as Excel, CSV, Oracle, Teradata, Amazon, etc. The free version is available for testing. There is big community support. You can get an answer to most of your questions within a large community. There are lots of tutorials available as well. It is very fast in creating charts. It is easy with the drag and drop option to create many visuals, including the data table. You can easily change from one chart to another. And now we will be doing some live examples. We will start off with the pivot table in Google Sheets. Okay, now I'm gonna share my screen and I'll give it a minute to show up for everyone. Okay, so now we're on Google Sheets and this is our data. So as you can see, we have a bunch of order data over here. So over here we have various categories such as order ID, order date, ship date, customer ID, etc., all tracking various information for hundreds and hundreds of orders going to different places. And we have other values such as profit, discount, quantity, etc., all to describe how our orders are. And as you can see, we have such a large size of data, it would be almost impossible to manually look through it for looking for trends or information. So now we will create a pivot table to properly visualize our data. First, we will start off by selecting our entire table to create the pivot table for. Then we will go to Data and click on Pivot Table. And as you can see, our data set is already selected over here with the proper columns from B to U. And then we will be clicking on Insert to New Sheet to create the pivot table on a new sheet. As you can see right now, the rows and values and columns are all empty because we have not selected anything for those fields. And on the right, you can see various settings and options that will help us fill out those fields and create a proper pivot table. We will start by showing profit by category. So we will take the category field and drag it into the rows. And as you can see, we have the various categories over here. And they're not repeating, they only brought the unique categories. Next, we will bring the profit to the value section. And now you can see the profits by values. And we will start by making a proper visual representation by displaying the pie chart for this. We'll select our data table, excluding the grand total because that should not be part of the pie chart. And then we'll click on chart. And that has created a proper pie chart, which can properly show the fractions of the various tools. Now we will show the profit by each category and segment. So now we will drag the regions into the columns to split up the columns into different regions based on central, east, west, and south. So we'll have the grand total for each category based on regions on the right, and then the overall total on the bottom. And then we will be selecting all our data except the grand totals, excluding the grand totals for the category and the regions. And now we'll create a new chart. And this chart will better represents the sales and the profits of each category within the different regions. And as you can see over here, in the central regions, we generally have lower sales in all categories, and as opposed to, and then you can see the differences in the furniture sold in the east compared to the furniture sold in other regions. Next up, we will be showing monthly profit. So we're gonna take the order date and put it into the rows. Right now it's sorted by every single date, but we're gonna change that into to group it up into months by right-clicking and selecting months. Now all the Google Sheets has taken all the dates and grouped them into months and properly categorized them. Now we will be displaying a time series chart for this data. Once again, we'll select everything except the grand total, and then insert and chart. And now, as we can see here, we have a proper time series chart to better analyze the data. And we can see it from this chart, we can see an unusual dip in July and then an overall increasing trend, upward trend. And now we will continue by using filters. So we will take the segments and put it into the filters category. And now we have filtered out 2 of the categories, and we only have the consumer left. And this is an updated chart to represent that. Okay, so these were the various tools and features we can use on Sheets, and this was only a small example. You can use large amounts of data and process it and make it into a proper visual form, and then use different tools such as filters to properly conduct a data analysis on this. Okay, now we'll be moving on to the next slide. So now that we have completed our hands-on on Google Sheets, we'll be moving on to data visualization with Tableau, which is another useful tool that we already talked about. I'm going to share my screen again to look at Tableau. Okay, and now we're going to be moving on to Tableau. So on Tableau, we have 2 data sets right now. One of them describes orders, and the other one describes games sold on Steam. So this is the same data set that we saw in Google Sheets, which has a lot of order information in a very large amount. And then this is another data set looking at Steam's various statistics in Steam's about purchases of different top-selling games, and then how often they were played or purchased. And we will also be looking at profits by segment. So now we have a new sheet over here. So we'll be dragging and dropping regions from the left into our rows category. And then as you can see, we have all the various regions here, but there are no values in our value section yet. But we'll be dragging profit onto the portion that says ABC, that's empty, to get our profit values in there. And now we have all our basic table. Then we can click Show Me and select the pie chart on the right to get a visualization. Now, even though we have a pie chart, we don't have proper labels for it yet, which is why we're going to drag regions onto the label section. And now we have the regions. And now, even though we have the regions, we don't have the profit on the labels, which is why we're going to want to control and drag. So now we have the labels, including the region and the profit for each region, along with the proper pie chart. We can also change the visualization type, for example, using this type of visualization. And then we can drag regions into columns and get some visualization like this. And they're also interchangeable, so you can look at it from different angles and different perspectives based on your needs. Next up, we'll be looking at a time series chart. So we'll be removing these by dragging them to the left and using order date. And for order date, we could split it up into months. Right now it's in years by clicking the plus on the left. And then it's split up into quarters. We'll click the plus again to split it up into months. And then now that it's in months, we can remove the quarter by dragging the quarter out to the left. And now our data is organized by year and then by month with the various values on the right. And then we can use different representations instead of a table. For example, over here, we can see a proper line chart. And then if we click the drop down and select month over here, then we can get an overall sum for all the months. So for example, over here, the point on April is a sum for all values of all Aprils from various years. Then we can drag order date onto color to compare different years over the same months and analyze common trends. For example, in 2016, there's an unusual spike in profit. And then in 2014, July, there was an unusual drop in profit. Okay, and then this is our Steam data set talking about top selling games, hours played, and number of purchases. And then at the bottom, I've already created a pie chart representation from which you can see how much Dota 2 has been played when compared to other games. And there's even though there's a key on the right, the labels on the pie chart are proper, so you can just look at that and understand the information. And then this is the dashboard, which can show multiple charts in one view from different perspectives and types. Okay, so that'll be it for our hands-on section. I'll get back to the slides. Okay, next up we'll be looking at forecasting. This is one of the many goals of data analysis, which is to provide forecasting. And as you can see here, we have various data points, and then we use those data points to make a line of best fit to try to consider all the data points as good as possible. And then in the third scenario, we have continued the line of best fit to predict the future trends based on past trends, as shown in the red line. Forecasting line of best fit. Linear regression creates the line of best fit. Y equals mx plus b is the formula for linear lines, and the line of best fit will try to minimize the error or deviation. As shown over here, the line of best fit tries to minimize the distance between all the data points to address future data points as accurately as possible. Now we will dive into nonlinear regression. Most of the time, a line may not represent the trend properly. We need to use nonlinear regression in those cases. As shown over here, based on the data points, you can see a trend that goes up and then down, which cannot be represented in linear y equals mx plus b, which is why we need a parabolic sort of shape over here. Next, we have data analysis Cabbage. Correlation versus causation. You can do a correlation analysis on two data points, but they're not necessarily impacting each other. For example, let's look at this graph on the right. On the x-axis, we have sunglasses sold, and on the y-axis, we have ice cream sales. And these are some data points, and overall, we can see an increasing trend. So the correlation between ice cream sales and sunglasses sold are shown. As the sales of ice cream is increasing, so do the sales of sunglasses. But sunglasses do not directly cause ice cream sales to go up. Just because a lot of sunglasses are sold, that is not causing more ice creams to be sold. They're simply a phenomenon caused by a different factor. Causation takes a step further. It says any change in the value of one variable will cause a change in the value of another variable. It is also referred to cause and effect. When a person is exercising, then the amount of calories burning goes up per minute. The former is causing the latter to happen. Now we'll look at confirmation bias. A confirmation bias results when researchers choose only the data that supports their own hypothesis. Data scientists exhibit confirmation bias when they actively seek to assign more weight to the evidence that confirms their hypothesis and ignores and underweighs other evidence that could disconfirm their hypothesis. Researchers need to be very careful, as given large amounts of data in a dataset, it can tell you anything you like. Now we'll be looking at advanced data analysis, such as text analysis, customer reviews and tweets, sentiment analysis, helpful for marketing outreach and politics, deep data mining, exploring finding data that is not directly visible or expected, and machine learning, such as neural networks and AI. Data analysis examples. The words they used, which is shown on the right in bubble. Now I'm gonna be showing you an example of how the New York Times properly used a bubble chart representation to show the number of words used in a debate. So then on the right you can see different words in different circles and the circle size representing how often the words were used. So this can give an high level overall idea of which words were used more and which words were used less by which sides, and can make a great comparison. Data analysis examples, military spending by country. As you can see here, we have different forms of the visualization of data, and we have larger bubbles representing larger numbers, smaller bubbles representing smaller numbers. Another example of visualization of data analysis is the global average temperature compared to the middle of the 20th century. Over here, we can see the temperature of the middle, and then we can see an overall increasing trend, and the rate of the increase also seems to be increasing over time. Now we have the mystery of the missing bus riders, another example of data analysis. This graph shows the bus ridership in Miami, Minneapolis, Atlanta, and Portland. Over here, we can see an overall decreasing trend, a major spike in Miami, and an overall stable trend for Portland, as we can see from 2012 to 2020. Next, we'll be looking at data analysis in the future. By 2023, the industry of data analysis is expected to be worth approximately $77 billion. 94% of enterprises say that analyzing data is more important for business growth and digital transformation. Companies that exploit the full potential of their data can increase their operating margins by 60%. Next up, some data analysis. You can use things like Kaggle.com, lots of free real data sets to play around with. They also have lots of scripts for machine learning and data analyses. Then we have Tableau Public, easy to create visualizations for free. And we have a Reddit called Data is Beautiful for some good visualizations. And then New York Times is also another good source. And then this is the end. You can, this concludes the presentation. I hope it has provided some good information. There are lots to be learned about the new data sets being generated every single day. I hope this gives you enough information to start your journey towards data analysis. And you can always reach out to me at drew.rai@hsnavigator.org. And this is my LinkedIn. If you want to connect to me, you can send a request, or if you want to contact me, you can use my LinkedIn as well. Okay, thank you for attending, and I'll be ending the meeting now.